Hi everybody, my name is Rosie Oakes and I'm currently a postdoc at the Academy of Natural Sciences in Philadelphia. And my research focuses on pteropods, which are a group of planktonic snails, planktonic mollusks. So you can see a picture here of them. They've changed the foot that a normal snail has into a pair of wings, and they swim through the ocean, which is what this video shows, which will not play, so you have to come to my poster later and I will show you, which was the better alternative than doing a dance, which was also the suggested remedy for this. So pteropods have had a lot of attention in research over the past 10 years. They form their shells from aragonite, which is the more soluble version of calcium carbonate, and they reach high abundances in the polar and subpolar regions, which are predicted to first go undersaturated with respect to aragonite. And this is important because pteropods are the potato chips, or crisps, of the ocean. And so they play a really important role in the ecosystem, particularly in these polar regions. So one of the big questions is how are pteropods going to respond once the water goes undersaturated with respect to aragonite? Now, pteropods have this organic coating on the outside of their shell. You can think about it kind of like the paint on your car. When that organic coating is pristine, it protects the shell underneath it. And when it chips, the shell underneath is exposed to the water on the outside of the shell. So what we were interested in testing is if pteropods are in these undersaturated environments and the periostracum, that organic layer, has been breached, do the shells dissolve? So we ran a series of incubation experiments in saturated seawater and slightly undersaturated seawater and highly undersaturated seawater with respect to aragonite. And incubated pteropods which have been sampled in quite a rough method so that the periostracums the organic layer had been breached during the collection of those shells. And what we found is in the undersaturated seawater, the pteropod shell did dissolve, but it was quite patchy. So we think that that organic layer probably is protecting the pteropod shell. So these are light microscope images here, but on my poster I also present some micro CT scans of the same pteropods, so you can see the localities of those dissolutions and how far that goes down into the original shell. So come by later to see the broken video and to talk more about my poster.